Thank you for this great opportunity to be able to share my research looking at screening for brain-based or cerebral visual impairment in children. So just as sort of a background on cerebral visual impairment, a very quick, brief background. It is a term used to describe visual issues caused by damage or injury to the visual brain. And around 40% of the brain is involved in the process of seeing. So it comes from many different areas in the brain involved in that process of actually allowing us to see what is in front of us. CVI, or cerebral visual impairment, is defined as a verifiable visual dysfunction which cannot be attributed to disorders of the anterior visual pathways or any potentially co-occurring ocular visual issues. And that was a definition that was put out in 2018 by Saki et al. And it's been a definition that has been used widely since then. However, early reports of visual issues observed in soldiers returning from World War One. So this was some of the first documentation about cerebral visual impairment was way back after World War One in soldiers, which was pretty amazing that it's been around for so long, but not very well understood and still not very diagnosed very well. It is the most common cause of vision impairment in children in the economically developed world. So some of the main causes of CVI, premature birth, so any babies born before 32 weeks have an 86% chance of having CVI. Other causes include lack of oxygen or low blood sugar at birth, closed head injuries, epilepsy, metabolic disorders, damage to specific brain locations, and infections of the central nervous system. So it can occur at any stage from pre-birth through to adulthood. And some of the main causes of CVI in adults is degenerative brain conditions or strokes, traumatic brain injuries, anything that impacts the brain. So the visual issues associated with CVI are reduced clarity of vision, difficulty seeing in certain parts of the visual field, problems with eye movement control, and challenges in recognition and interpreting visual information. So those visual perceptual difficulties. So to define that a little bit more, visual perceptual difficulties cause difficulty recognizing objects or people, difficulty understanding spatial relationships, and difficulty processing moving in all complex visual scenes. So we've had some great research come out of the CVI neuroplasticity lab at Harvard in recent years that have helped us to see some of the key indicators of visual perceptual difficulties, especially in children. So it's darting eye movements, slower processing of the visual scene as the complexity increases. So as there's more to see and there's more to visually process, children with visual perceptual difficulties have more difficulty in seeing what there is to see. Worsening performance with increased task demand. So as there's more to see and more intense tasks to do, it makes it harder for children to see and process that information. Slower response time to visual stimuli. So there's a delay in when they first see a visual scene or they first see the information in front of them and it's that processing time in terms of processing what they see and being able to understand that information. Difficulties with visually guided movement, and then also increased levels of frustration and anxiety. So the visual issues also cause an emotional reaction. So there's children with visual perceptual difficulties, CVI, often have emotional regulation difficulties. The best way to explain what CVI is through this simulation that was created by the team at St Andrews University in CVI Scotland. So this is a simulation of what it's like to have CVI. I'm talking about it in a mainstream school children context.
What is a visual perception difficulty? What does it look like compared to typical vision? How can you explain and show what it might look like through the eyes of someone with cerebral visual impairment, or CVI? Through our work developing CVI Sim, we are finding new ways of understanding and showing visual perception difficulties caused by CVI. First, we need to understand the process behind the difficulties. As you move, things around you are seen to move. They are being constantly mapped and remapped by your brain relative to yourself. It happens quickly, so often it seems seamless. This means you can move around safely without bumping into things and reach for things accurately with no accidents. It is, however, a massive brain process. The more to map and remap, the harder the brain has to work. This mapping process is key to vision. Only what is mapped, however, gains our visual attention. Visual attention is needed for you to be able to change your direction of gaze to see and recognize things. Visual perception difficulties due to CVI are often associated with visual attention not working properly. This is called simultaneous agnosia. Simultaneous agnosia is often felt to be present if someone finds it hard to see one or two things in a scene at the same time. That is, however, only one outcome of these visual perception difficulties. We are learning that there are more ways that this can become manifest, and that this form of CVI can be mild as well as severe. When mild, for some, when in an open place, their vision may be very similar to vision without CVI. But as their brain needs to map and remap more complexity, the process can't keep up and cope, and vision is affected. Those affected, especially if born with it, are not necessarily aware their vision is changing, as it is an unconscious process. Using CVI Sim, we can show what it might be like to see the world with simultaneous agnosia. As the brain has to work harder to map more, it reaches a point where it can't handle everything, so not everything is mapped. What is not mapped is not available for the person to see, meaning sometimes only one or two things at a time can be seen. So, when in a place with lots of things to map, the person with this form of CVI may have to build up the visual scene one element at a time. This can be difficult and stressful, all adding to the demands on the brain. Without realizing it, the person can be losing control of their vision and may find it difficult to stay focused on one thing. This can become mentally exhausting, further adding demands to a brain that is now really struggling, to a point where they are completely overwhelmed and can't function. This form of CVI is often accompanied with mild lower visual field impairment. An affected person is unlikely to run down a flight of stairs, especially if there's no handrail. They may have found team sports like soccer and hockey difficult. Many are academically very able in school, but because of CVI, they have to work much harder than the other children. Sometimes the term mild visual perception difficulties due to CVI is used for this form of CVI. Using CVI Sim, we may be able to show what mild CVI looks like, but there is nothing mild about the challenges it creates. One study has found that 80% of children with this form of CVI in mainstream schools can have difficulties. This is probably the most common form of CVI. Simple strategies can help reduce the burden on the brain, allowing the child to thrive.
So that was a very brief overview of CVI in such a short time frame. But so the impact that CVI can have in an education context is that children can struggle to stay focused on learning tasks. They can be easily distracted by competing sensory information. They may find it difficult to copy or to keep up with the information being presented to them in the classroom. They may be overly sensitive and startle often to movement and noise. And there's often disparities in the child's functioning from day to day, even from morning to afternoon, and high levels of visual and overall fatigue. And this can hugely impact in an education context and their learning. So there's a need for a validated screening tool because currently there wasn't a validated screening tool that was easily used for this context. And the reason that we need one is that there's a prevalence rate of around 3.4% of children in mainstream education. So one child in every classroom has these visual issues. Obviously, a huge impact on an education context, especially when undiagnosed. Many children with visual perceptual difficulties or CVI have typical or near typical visual acuity, which makes it hard for them to be identified as having visual issues. If they go to their optometrist and they can read to the bottom of the eye chart, they don't get picked up as having visual issues. And vision is often not considered in relation to learning and behaviour difficulties that's happening at school. So in research that I did looking at children in a mainstream school, all of the children in my research had been identified as having some kind of learning support needs, so ADHD, autism, dyspraxia, dyslexia, auditory processing, but actually no one had worked out that the vision was what was causing many of the challenges that they were facing. And visual perceptual difficulties can appear difficult. It can be difficult to assess because they appear different in clinical settings as opposed to real world situations. And there's currently limited validation screening tools available. So I developed a screening tool for CVI with the visual perceptual difficulties called the Austin Assessment app. And it was created following an experience working with a young boy called Austin who had cerebral palsy and CVI. It was originally developed as a functional vision assessment tool for teachers working with children who are blind and low vision to be able to assess what their look at what their CVI needs were. It's a simple and fun matching activity, 2 rounds, and it can be done on an iPad or an iPhone. Some of the main underlying principles of the Austin assessment is that it's child-centered and strengths-based. So the children do not know they're being assessed. It's a fun, engaging game that they play, and it's meant to show what they can do, not necessarily what the focus on what they can't do. Here is a video about a demonstration of the Austin assessment, which will make it a lot easier to understand how it works.
Firstly, make sure the child is somewhere quiet and ideally with minimal clutter. Importantly, do not use the practice mode before the screening, as this might impact and so invalidate the result. Hand the device to the child. First, the eye tracking needs to calibrate, then the child should click Continue. The child swipes with their fingers to match the pairs. The first game screen you will see is a tutorial level. Once this is done, you can move on to the first level where the assessment starts. On level 1, where there is 4 cards, as soon as they swipe the first pair, the test starts. They need to click Done and continue after each level.
This child does not have CVI, so they're finding it.
After the first round, the test will pause until the child clicks Continue, and then the second round starts. If there are any mistakes or cards are left when the child presses Continue, the test will continue. Do not tell the child they have made a mistake. This is important as we don't want them to ever feel like they have done it wrong.
Children with CVI take a lot longer to match the pairs at each level than children with typical vision, and this child has typical vision, so is moving through it quite fast. The reason for having multicoloured and then single coloured is that some children found the multicoloured easier than the single colour and vice versa, and some found the colour distracting.
Add the child's name and, very importantly, their age, as this has an impact on the results. You can also add known conditions, although this will not have an impact on the results, but might be useful for the report. There are 3 measures: time to complete, accuracy meaning correct matches, and dwell time, which is the time it takes to match the first pair at each level. The results are shown for round 1 and round 2. A green tick means the child's performance is within the typical range for a child of their age. An orange asterisk means the child's performance indicates they may have visual difficulties relating to CVI, and further assessment with your local vision specialist is recommended. You will also see the visual search images from the eye tracker. These currently do not form part of the measured test, but might be of interest. With CVI, the visual search pattern can be considerably different. At the top of the results screen is an option to share, save or print the results.
So just a quick overview of how it works. And so I mentioned before the key indicators of issues with the higher visual functions. And so that's what the app measuring. It's measuring the time taken to match the pairs at all 5 levels, the accuracy to match the pairs, the time taken to match the first pair, which is the dwell time, and that links with that slower response time to visual stimuli, and then the eye movement while matching the pairs. So the measurements of the app are linked with those key indicators that I mentioned earlier. There's a normative range for age groups 5 to 8, 9 to 12, and 13 to 18, and thresholds for 3 variables. So a total of 6 variables across the multicoloured and the single-coloured. And only one threshold needs to be met for a child for it to indicate that a child needs further assessment. I know I'm running out of time, so I'll just do a quick overview of the research. So there has been numerous research projects that have gone into developing and validating the Austin assessment. I've assessed over 900 children aged between 5 and 18 for this validation. It's been user tested in industry-based research, and I'm also working on an adult normative range currently. So just a little bit more about the research that's happened. So the pilot study was the first one, which was done with playing cards as opposed to when it was just the idea, and it was so effective. The research showed that it was so effective at identifying children that potentially have visual issues associated with CVI that I got some funding to be able to turn it into the iPad app. And so this was one of the key indicators to us that was working. So the orange dots are the children with the controlled group who had typical vision, and the blue asterisks or the crosses were the children who had the visual search issues. And you can see that the number of cards how long it took them to match a pair of cards when there were 4 cards in the lower one and then 12 cards at the top. And you see the control children took pretty much the same amount of time when there were 4 cards to 12 cards, but the children in the research group took a lot longer when there was more cards for them to process. The normative range database assessed 724 children. The data was analysed to work out the age groupings, and then percentiles were used for the overall time and dwell time. We went for the 85th percentile for the children aged 5 to 8 because their vision is just maturing, and they were a bit more chaotic at how they did the app, whereas the 95th percentile for the older children. And this was looking at the age grouping for the multicoloured round, and you can see that natural grouping of 5 to 8, 9 to 12, and 13 to 18, and that's in line with visual maturation and visual maturity. And then there was a similar age grouping with the single coloured round as well. I then looked at it as effectiveness of a screening tool. So we assessed 271 children aged between 5 and 13. And any child that met the threshold on one threshold on the assessment was assessed by an ophthalmologist, an orthoptist, and myself. And we found 17 children that had a verifiable reason or clinical finding that made the results on the Austin assessment a reliable, true positive. So out of those 271, we found 17 children who were further assessed and confirmed to have a visual issue that wasn't likely to be of CVI. Further assessment was needed to confirm that because we were doing it in a classroom in a school setting, and we didn't have a full battery of assessment tools to be able to conduct that research that was needed. And then also I did the final research with the validation research, where I assessed 149 children with the Austin assessment and an already validated visual search tool, the teddy bear test for the young children or the cancellation test for the older children. 129 of these children had conditions, CVI, cerebral palsy, born premature, and 30 children had typical vision. And this research showed that the Austin assessment had moderate diagnostic value for each age group with a good sensitivity and specificity. And it showed that it was effective at distinguishing between children with visual issues from those with typical vision. So the Austin assessment is available on the App Store. There's a family app and a work app. It's been downloaded in 46 countries around the world, over 1,100 screenings conducted. Feedback from users is that the Austin assessment, this is apparent, the Austin assessment app is beyond amazing. For a clinician, the laser eyes at the beginning are a stroke of genius, very engaging. And from a researcher, the kids all love the Austin assessment as their favourite part of the vision testing. So The apps are available on the App Store. I know I've gone through this a little bit fast, but the Austin Assessment Work app is available, which they're both free to download. The Austin Assessment Family, the Austin Assessment Family is for individuals and families that want to screen children or themselves, and the Austin Assessment Work is for people working in that will be assessing more children, so in teachers, rehab, clinicians, researchers, and the QR codes there can be used to find both of the apps on the App Store. Very brief gone through, but I know I've gone over time, so thank you.